Okay, so this is example 2 from the chapter 2H notes packet. And in this one, we've got this rational function, f of x equals x minus 1 over x squared minus x minus 6. And it says graph it. And so there's going to be a method that we use to graphing these things. We're always going to find x-intercepts, y-intercepts, any horizontal asymptotes, any vertical asymptotes, and then we're going to make a sign chart. And you'll see that that's basically all you need to get quite a lot of detail out of the graph. So probably what would be useful, I'm going to write f of x here again. Let me use a thin. F of x equals x minus 1 over x squared minus x minus 6. And usually you want factored form too. That comes in handy. So this one would be x minus 3 on the bottom, x plus 2. Okay, so x-intercepts. Let's list those off. So the x-intercepts mean set y equal to 0. And if y equals 0, that's saying the whole thing equals 0. Well, the only way the whole thing can equal 0 is if the numerator is 0. So this is the same thing as saying set x minus 1 equal to 0, and so you get x equals 1. Okay, so now we know that the x-intercept and the only x-intercept is 1, 0. So let's look at y-intercepts. Okay, so that being set x equal to 0. Now you can plug in 0 into that, but it's usually easier to get the y-intercepts from the original unfactored form, because if you plug in 0 there, everything goes away except for the negative 1 on top and the negative 6 on the bottom, so we get 1/6. So 0, 1/6 there. Okay, so that's the only y-intercept. Vertical asymptotes, I think people are pretty comfortable with that now. It's the stuff that didn't cancel, and since nothing on the bottom cancels, we can get x equals 3 and x equals negative 2 are the vertical asymptotes. And then horizontal asymptotes. Well, this is a function that has x minus 1. Oh, it has a dominant term of x on top and a dominant term of x squared on the bottom. That's going to simplify to be 1 over x, and out at the ends, 1 over x approaches 0, both with positive and negative infinity. One thing I want you to notice from the previous example up here, if I can scroll up, when we did long division here, 3 was the quotient. 3 also ends up being this horizontal asymptote right there. If I did long division on this thing, x squared minus x minus 6, x minus 1, you would end up, wait a minute. Sorry, that's the wrong way around. The x minus 1 has to go on the inside. X minus 1 here, x squared minus x minus 6. And really what you would get is 0 with everything left over as the remainder. So, so you'd end up with x minus 1 over x squared minus x minus 6 if you write this out from the original. So 0 is the asymptote. The quotient, it always ends up being the asymptote. So this is going to be y equals 0 is the asymptote. We'll review this more later on, so if you don't quite understand it yet, don't worry about it. We'll come back to it. Where's the x? How do I delete that? There we go. Okay. So let's make a sign chart. Okay, now the sign chart, one of the things that we've been doing, we've always put the zeros on it, and there's only 1 0 at 1, 0. So when x is 1, f of x is 0. But now what we're going to do is we're also going to put anywhere that it's undefined on there. So it's got vertical asymptotes at 3 and negative 2, so I'm also going to put 3 here and negative 2 here. And those are undefined. They're asymptotes there. So I'm going to put that there too. Now let's test some points. So if I plugged in something less than negative 2, the top's going to be negative, the bottom x minus 3 is going to be negative, this x plus 2 is also going to be negative, so it's negative over 2 negatives. That's going to be a negative. I already have a test point that I plugged in here. That was when x is 0, y was positive. If I plug in a 2, let's say, numerator is positive, this would be negative, this would be positive, so the whole thing would be negative. And if I plugged in, let's say, x equals 4, then this is going to be positive, positive, positive. So I'm going to get positive here. So now let's graph the thing. So here we go. Here's 3, here's 1, here's -1, -2. I know that I have asymptotes at 3 and -2. So I'm going to label these x equals 3, x equals -2. I know I have a horizontal asymptote at y equals 0. And then the rest of this, it's got to go through 1, 0. It has to go through 0, 1, 6. So let's call that 1. So 0, 1, 6 would be about here. And then let's use the sign chart. So I have to stay negative the entire time I'm to the left of -2. So if I got to stay negative and I have this asymptote, these asymptotes here, the only thing that it can do is this. Right there. Then I have to be positive right after it until I get to the 0 at 1. So it's going to do something like this. Can't start out down here because then I'd be negative, and I have to hug that asymptote, the vertical asymptote. Then it goes negative. So if I come out of here, I've got nowhere to go but down. And then I have to be positive after that. So that's going to be this. And there are really no other options here. One other thing that you're going to have to start doing is using limit notation. You're going to have to write out the limit notation stuff. So just to do a few examples on here, like if I'm looking at this part, limits can always be used to describe asymptotes. So like this one right here says, the way I would describe that is the limit as x is going to 3, and I'm on the I'm on the left side of 3, so minus, right, of f of x approaches -infinity. So as x gets close to 3 from the left side, y turns into -infinity. If I'm looking at like this one, let's say, right, that would be the limit as x goes to -2 from the right side, and the y values approach infinity. If I'm looking at this one right here, that would be the limit as x goes to infinity, and f of x turns into 0. So those are some examples of ways to write out those asymptotes as limits.